Okay, so I have to tear it out of my notebook. Yeah, you don't have to tear it out. Okay. Okay, guys, so we're in 11.4, and we're talking about simplifying rational expressions. Simplifying rational expressions. What does it mean to be rational? Not rational in the sense of like English, like rational in numbers. What's a rational number?
Oh, it goes on.
Real number?
A number that can
A decimal that goes on and on forever. It is a real number.
Pi. A
No,
number
pi.
that can be written as a quotient of 2 and 2.
Pi isn't because it goes on and on forever without repeating.
Oh.
Yeah. Yeah, to be a rational number, it has to repeat or terminate. Now let's think about that. Decimals that repeat or terminate could also be written as fractions. A rational number is something that can be written as a fraction, okay? And so that's what we're working today, is simplifying fractions that have expressions in them, okay? Well, we had to do factoring yesterday because that's the number one thing we're going to do when we work with rational expressions, is you have to factor first. So in your notes, okay, first off, I want to write a rational expression is a fraction Okay, so anytime you hear that rational expression, you're thinking fractions. And to simplify, you're going to factor the numerator and denominator. Can everybody see red okay? Can I write red?
Mm-hmm.
What?
Yeah.
Okay. Factor the numerator and denominator and cancel if possible. Okay? That's the first thing we're going to do. That's what example 1 talks about. So take a look at example 1. And we're just going to look at example 1a. Example 1a says 2x over 2 times the quantity of x plus 5. So the first thing we're looking at, remember, is can I factor? Well, if you look up in the top, how many terms are there? One term, okay? Do we have anything in our factor sheet that says we can factor one term? No, we've worked with 2 terms, 3 terms, 4 terms, okay, but never one term. So he's got to be done. In the bottom, what do you notice they've already done for us? They already factored because, check it out, they took a 2 out and they showed us what was left, x plus 5. And if I look at that x plus 5 for 2 terms, can I take any more out? Are they difference of squares? No. It's addition for 1, and neither one of them are square terms. So they've already done the factoring for us. So now we're ready to see if we can cancel, okay? Well, when you look at the top and the bottom, do you see anything that might be able to cancel? The 2's. And I want you guys to think about numbers are separate than variables, and they are separate than sets. So if I look at my numbers first, 2 and 2 out here at the front, yes, those can cancel. Then if I look at the x, when I'm looking at x, I'm saying that there has to be an x out front, all by himself, that he could cancel with. Is there?
No.
No. Okay, so he's going to have to stay. And then I'm going to look at sets. Well, I'm talking about what's in parentheses. Do you have anything in parentheses that looks exactly like x plus 5?
No.
No. So my final answer, x is on top, and x plus 5 is in the bottom. There's my final answer. Now, like I said, that was relatively easy because they did the factoring for us, okay? So once it's factored, you can start canceling. The thing I want you to remember is I can never separate a set, meaning I couldn't have said I could cancel that x with that x because he's locked in with that plus 5. Okay? Let's take a look at example 2. Example 2 says 2x squared minus 6x over 6x squared, right? Yeah. So they haven't factored this for us. So if we take a look at the top, Casey, how many terms?
2.
2 terms. First question, Logan. First question. Factor. Remember, we got to factor, factor, factor first before we start crossing things out. Can you take anything out? Erin, when you take a look at the top, can you take anything out?
2.
I can take a 2. Anything else?
X.
I can take an x out. They both have x's. Now, when I take a 2x out, Alyssa, what's left? Good. X minus 3. 2 divided by 2 is gone. X squared divided by x is x. 6 divided by 2 is 3. X over x would be gone. Okay, over. In the bottom, Brendan, we have 1 term. Can I factor 1 term? No, we have nothing on our factor sheet that talks about factoring 1 term. So we just carry him down. Now, once I factored Emma, now I can start canceling things out. Let's start with our numbers. Can I cancel my numbers of 2 and 6? You can reduce, yeah. What would that reduce to?
1/3.
Okay, so he's gone, and he's going down to a 3, right? Okay. Cullen, now let's look at our x's. And I'm talking about x's that are not in sets. So we have an x here, and we have an x squared in the bottom.
We can take out the top x.
Okay.
It'll be nothing, then that bottom would just be x.
Okay, so we're canceling like we did with our exponent rules. Breton, now let's look at our sets. Do I have an x minus 3 in the bottom?
No.
No. So the x minus 3 cannot be canceled because remember, he has to be canceled as one set altogether. So my final answer, what's left on top? X minus 3, and on the bottom? Over 3x. Factor, 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 then you can cross some things off. Okay? Alright? Let's look at example 3. Pierce, can you see everything in that screen?
Yeah.
Okay. Alright, Landon, you want to read that for me?
4 minus x squared over x squared minus x minus 2.
Remember, before you start crossing things off, you have to factor, factor, factor. Pierce, let's start with the top. How many terms?
2.
2 terms. First question, Allison.
Can you take anything out?
Can you take anything out? Landon, can you take anything out of the top?
No.
No. Next question.
Are they both terms square numbers?
Are both terms square numbers?
No.
Which one's not?
Or yes. No.
Yes. Yes, it is. Is it a difference of squares?
Yes.
Yes, because what's difference mean, guys?
Subtraction.
Subtraction. Yeah, it's a difference of squares. What are their roots, Anna? 2 and x. So then, Anna, what's my pattern for difference of squares? A plus B, A minus B. So in this case, it would be 2 plus x and 2 minus x. We factored the top. It's in a little different order than we're used to, but it still works. Okay? Now let's take a look at the bottom. Brandon, how many terms?
3.
3 terms. First question.
Can you take anything out?
Can I take anything out of all 3 of those terms? Adriana, what do you think? No. Next question. Where's your factor sheet? Are the first and the third perfect squares? Maddie, what do you think? No, which one's not? 2 is not a perfect square. So then, Maddie, what am I going to do then? Proceed with general factoring. Remember, 2 sets of parentheses. You're factoring this piece right here, guys. Okay? What do you think, Breton? What's going to go in the first spots? Remember, we're factoring this.
And is it the same pattern for the bottom?
We're doing general factoring, so we've got to figure out the pattern. So factors of x squared.
1 times 1.
Okay, so x times x. Factors of 2.
1 times 2.
Good, those are my only factors, right? So there's no guessing and testing. Let's just put them in. Okay? Logan, help me with my check. 1x. And I'm trying to get to negative x, Logan. Very good. The 1 is positive and the 2 is negative. Nice job. And I'm going to erase my check from here because remember, I don't really need that for my answer. That just helped me do my factoring. Okay. Now, do I have any numbers out front? Do I have any numbers out front of my sets?
No.
No. Do I have any variables out front of my sets? No, like I did here when I had the 2x out front? No. So I'm ready to cancel sets. But I don't have any sets that look exactly the same. So if I look at this right now, nothing can cancel. But is there something that looks very similar?
Talking about them on the right.
What is the difference between 2 minus x and x minus 2?
The order.
The order is different, okay? Because the order is different, what's different about them?
So negative x and
Okay, up here, we have a positive 2 and a negative x. Down here, we have a positive x and a negative 2. How could I make this guy look like this guy if the only difference is their signs?
change left of it, every change.
How?
Okay, flip the first one next.
Think about that one problem on grouping last night, guys. It was 2x plus 3, and then the other side was negative 2x minus 3. They were so close.
You had to multiply it by negative 1.
You had to take out a negative 1. If I take a negative 1 out of this guy, that's going to make him negative 2 plus x. Or we could write that as
X minus 2.
x minus 2 now. Okay? So because I pulled a negative 1, it switched all of this guy's signs. And I only pulled it out of this set. Okay? That switched his signs. And that way when I change his order, now he's exactly like the bottom. Meaning what's going to happen?
Cross them out.
Now I can cross them out. And when I say cross them out, I am crossing out that entire set. Can anything else cross out? No. So my final answer, I'm going to put this negative 1 out front. Then I've got the 2 plus x. And in the bottom, I have x plus 1. That's a tricky one, guys. I will admit. You don't see that a ton, but that is a tricky one. Just remember, when you pull out that negative, all of your signs have to change in that set. Okay? When you take out that negative, all of your signs have to change. Questions there? Aaron?
So why did you have to bring the -1 back out in front of the 2 plus x if you're not changing that one?
Because if I put it here, what's it look like?
-1?
It looks like this set -1, and that wasn't the case. Think about what was happening. What operation is between this and this? Multiplication. So technically you have 2 plus x times -1 times 2 minus x. And what do you know about multiplication, guys, as far as order? It's commutative. It doesn't matter, okay? So I pulled it out here to show that I was just taking it out of this piece, but then when I write my final answer, the order, so to speak, doesn't matter. I mean, I could have written it like this, Aaron. It means the same thing, but we usually put the numbers all the way out front. Okay? Good question. Okay? Let's try one more of those. One more of those. Everybody got that down? Okay. We are going to try. Just call this one example 1 star, and we have x squared plus 4x plus 3 over x squared plus x. Factor, factor, factor before you start crossing things out. Brendan, let's start with the top. How many terms?
3.
First question.
Can you take anything out?
Adriana, can I take anything out of all 3 terms? Next question. Are the first and the third perfect squares? No, which one's not? 3 is not a perfect square. Okay, Cullen, so then I'm going to use general factoring. Okay, we're factoring the top here, guys. 2 sets of parentheses. Brandon, x squared is going to split up into x and x. Factors of 3? 1 and 3. Alyssa, help me with my check. 1x and 3x. I'm trying to get to 4x. What do you think, Allison? What would my signs need to be here to get a positive 4x? They're both positive. Very good. Remember, your final check is 1 times 3 still 3? Yes, it is. Now again, I'm going to erase my check because I don't need it for my answer. Okay, now let's work on the bottom. Casey, in the bottom, how many terms?
2.
2 terms. First question.
Can you take anything out?
Can you take anything out? Pierce, looking at the bottom, can I take anything out?
Well, yeah.
Yeah. What do they both have?
X.
Yeah, they both have an X. What's left, Pierce?
X. And that's it, right?
Divide. X squared divided by x is x. X divided by x is
X.
2 divided by 2, 3 divided by 3. 1. There you go, plus 1. Remember, a term can never just disappear, guys. There has to be a place for it. Now that I have everything factored, Aaron, do you see anything that looks like I could cancel it?
The set of x plus 1.
The set of x plus 1. I like how she said that. You have to cancel the entire thing. You are not saying, oh, I'm crossing out the x's and the 1's. I am crossing out the x plus 1 with the x plus 1. Anything else, Anna? No. Final answer? Very good. Remember, you cannot cancel these x's because technically he's a set. He cannot be separated from that plus 3. Landon?
Do you care if we saw the parentheses on them?
No, you can write it like this. That doesn't bother me. Okay? So that's the first part of this. That is simplifying, okay? That is simplifying. Now, step 2 on example 4 says, recognizing when an expression is undefined. What does it mean to be undefined?
Not solvable.
It's not solvable, okay? What else? What else do you guys think of when you hear the word undefined?
Hasn't thought of it.
A vertical line has undefined slope. Why does it have undefined slope? Because there is 0 in the bottom. That's exactly right. Undefined means that there is 0 in the bottom. So you cannot have 0 in the denominator. We can never, ever, ever divide by 0, guys. Okay? Or we call that undefined. We can't work it. We can't do something like that. If you put it into your calculator, you're going to get an error. So what they're going to ask us today is, they're going to say, for what values would this rational expression meaning a fraction, they're going to say, for what values would this be undefined? What does that mean? If it's undefined, it means its denominator is 0. So, to determine that, you want to take your denominator and you want to set the denominator equal to 0. And solve for x. This value will make it undefined. So I'm going to write the final answers of the ones that we've just done. Okay? Here is our example 1 star. Example 1A was x over x plus 5. This was just the answer. And then example 2's answer was x minus 3 over 3x. You should have them in your notes already. And then example 3's, markers. Example 3's answer was x plus 2 over x plus 1. Okay? So let's look at these all individually. Okay? And if you want to rewrite them, for example 4, you can. Okay? Or you can just write this out to the side of each problem. I'm okay with that too. So if we were going to prove when example 1 star is undefined, it says set its denominator equal to 0 and solve for x. So if I look at this problem right here, his denominator, Alyssa, is x, and I'm supposed to set it equal to, alright? And then I'm supposed to solve for x, meaning I'm supposed to get x by itself. But what do you notice? X is by itself, meaning when is this fraction going to be undefined? When x equals 0. Okay? So x equals 0 will be undefined. That one was easy because it was the only thing in the denominator. Let's take a look at example 1a. If we were going to look at this answer and say, when is this answer undefined? Remember it says take the denominator and set it equal to 0. Well, Pierce, what's my denominator?
X plus 5.
X plus 5. So if I take x plus 5 and set it equal to 0, then I'm supposed to solve. Well, Breton, how would I get x by itself here?
Subtract the 5.
Subtract the 5 to the other side, meaning x equals, anybody? -5. And what does this mean, guys?
That'll be when it's undefined.
When x is -5, this rational expression will be undefined. We won't be able to do it because there will be 0 in the denominator. -5 plus 5 gives me 0. Okay? So x cannot ever be -5 in this rational expression, or that's going to give me 0 in the denominator. It's going to give me an error. because negative 5 plus 5 would give me 0, and I can never divide by 0. So when x is negative 5, that will make it undefined. Okay, let's take a look at example 2. Example 2's answer was x minus 3 over 3x. So Allison, if we were trying to find values of when this would be undefined, what am I going to do?
Multiply 3 by 0. Or x will equal 0.
Okay, why? What do I need to do first?
Make it undefined.
Take the denominator and
Oh, set the denominator to 0.
set the denominator equal to 0. So 3x equals 0. And then I need to solve. Well, Logan, how am I going to get x by itself? Divide by 3. And guys, what's 0 divided by 3? 0. I can do 0 divided by 3. And what does this mean, Adriana? When x is 0, my rational expression will be undefined. Because think about that. 3 times 0 is going to be 0. You'll have 0 in the denominator. So x equals 0 will be undefined. You will not be able to do that. Better write that out. Okay. Last one, Maddie. Example 3's answer was x plus 2 over x plus 1. How am I going to find the value for when this is undefined?
Set denominator to 0.
Set the denominator, x plus 1, equal to 0. Now, Casey, how am I going to get x by itself?
Subtract 1.
Subtract 1 so that x is
Negative 1.
-1. And Landon, what does this mean?
Means that when it's negative 1, then it will be undefined.
That's right. When x is -1, this fraction will be undefined. I cannot do this problem if x is -1. Okay, now granted, I know we're not solving right now, but later on, you will be. Okay, so you need to understand that. I'm going to show you what I mean by that here in a second. Okay, if you guys take a look over here at what Algebra 2 was doing this morning, I know the video's not going to be able to see this, but it's okay. This was their original problem, okay? And they were solving. They came all the way down here, they solved. Oh my gosh, look what they did right here. What would we call this?
Factor.
They factored to find their solutions, and they came up with solutions of 4 and 2. But then we crossed 2 out, because if we put 2 back in here, look at your denominators. If we put 2 back in here, 2 minus 2 is 0. That can't work. I can never do that. That's a perfect example of how you will use this later on.
Is that what you
Okay. No, it's not. It's just total coincidence. But I was thinking of you guys this morning when we factored. Okay? So that's the second part of your homework. That's the second part of your homework, is determining when a rational expression is undefined. Okay? Turn the page 666. All right. On the third page, we are talking about geometric probability. Now, you guys have actually done a little bit of this, okay? Geometric probability. Anybody remember what we know about probability? Of how to find it?
Number of favorable over total.
Favorable over total. Very good. It's what I want over the total piece, okay? So remember when we were doing our examples of like hitting the bullseye, okay? And we wanted to hit the bullseye, but we had it over that entire target. Do you guys kind of remember doing that?
No.
Okay? That's an example of geometric probability. So if you take a look at page 666, it says to find geometric probability, we have to take the favorable area, the area that I want, like the bullseye example, over the total area. Now guys, if we're dealing with area, you better know your area formulas. Area of a rectangle Length times width. Area of a circle,
Pi r squared.
pi r squared. Area of a triangle,
Base times height divided by 2.
base times height divided by 2. Okay, you better know those. Let's take a look at example 5. I'm going to draw this picture up so we're all looking at the same thing. I'm not going to use 2 colors because mine aren't working well today. But we've got this figure in the middle that has dimensions of x and x plus 2. And then we have the big figure that's 3x by 4x minus 4. And it says, a coin is tossed onto the larger rectangular region shown at the right, meaning a coin is tossed onto the blue region. It is equally likely to land on any point in that region. So the first part says, write a model,
Equation.
an equation that gives the probability that the coin will land in the small rectangle. Okay, so let's do that first. What do we want? Where do we want our coin to land? In the small region. So if we write this out, we are finding a probability that it will land in the small region, because that's what we want, over total. Total is going to be what?
The whole thing.
The whole thing. So if we write it out in words, we kind of know exactly what we're finding here. Now, if we look at our formula, it says we need the favorable area. So we need the area of the small region. Well, the small region is in what shape, Breton?
Rectangle.
A rectangle. And how do I find area of a rectangle? Length times width. In this case, Brendan, what's my length and my width?
X and X plus 2.
There you go. So you're taking x times x plus 2. Then we're supposed to take it over the total area, or the area of the whole thing. Well, the whole thing, Maddie, is in what shape? An area of a rectangle? Length times width. In this case?
3x times 4x minus 4.
Now remember what we're doing today. If we have a rational expression, we could possibly cancel it if everything is factored. Does anybody see anything here that could be factored?
X out in front.
Alyssa, what did you say?
4x minus 4.
The 4x minus 4. Why could this set be factored further? Yeah, 2 terms. Can I take anything out? I can take a 4 out front. So if I take a 4 out front of this, I still have this 3x here. What's left, Alyssa, if I divide this by 4?
X minus 2.
You took out 4. 4 divided by 4. There you go. Okay? Notice I left the 3x alone. I took the 4 all the way out front. We're going to clean it up.
Would it matter if they're switched around if it's like
No.
3x?
Times 4. All right? So I could take this one step further and say that this would be x over x plus 2, and then 4 times 3x is 12x over x minus 1. Now, Pierce, I heard you back there. 12x, x minus 1. Now that I have it factored, Pierce, do you see anything that I could cancel?
Like top and
Top and bottom what? Numbers, variables, sets.
I don't see anything.
Nothing's the same in the top and the bottom?
Oh,
Anything?
the x's.
The x is very good. You've got an x here and an x here, so they could cancel. Anything else, guys? No, so I have x plus 2 over 12 x minus 1. There's my model right there. There's part A. We set up our geometric probability. We factored as far as we could. Alyssa took this one farther. Then we canceled. Okay? Now on part B, it says evaluate the model when x is 10. So what am I going to do? Sub 10 in for x. Okay? So if x equals 10, we're going to put that in for x of our final model. So we had 10 plus 2 over 12 times 10 minus 1. Notice I just put the 10 in. I put the 10 into this wherever there was an x. Brandon, can you clean that up for me?
12 over 12 times 189.
Good. Or I could just say 12 times 9. What is 12 times 9, Logan? Yeah, I don't know either, but you've got that fancy calculator there. 108. So we have 12 over 108. Now we're talking probability, guys. I could leave it like this, or I could write it as a
Fraction.
Reduce.
decimal, so that then I could write it as a percent. Let's write it as a percent. So what is 12 divided by 108? What? What was that? Oh, I thought you had it.
1.111.
Okay, stop muttering and somebody say it.
0.1111.
0.11, repeating. So that percent would be 11.1%. You don't want to write the repeating. 11.1%. Now, when I look at their problem, they actually did write it as a fraction. They reduced 12 over 108. I'm okay with either one, I guess. Normally, you see this as a percent, because you would say there's an 11% chance that you would hit that small rectangle. Okay? Questions there? Okay? Let's see if we can get one more in. Let's take a look at page 667 and look at number 8. Okay, now number 8 has this skinny picture like this. The small one has dimensions of x and x plus 4. The big one has dimensions of 2x and 2x squared plus 8x. And the question is asking me what is the, well, it's actually asking me which ratio represents the smaller rectangle over the bigger rectangle. But let's just do the same thing. Let's say what's the probability of hitting the smaller region, the darker region, okay? So again, remember favorable area over total area. So in this case, if I want to hit the small, I want the small rectangle over the big rectangle, okay? So the area of the small over the area of the total, or the big in this case. Breton, how am I going to find area of the small?
Length times width.
Length times width, and in this case?
X times x plus 4.
Very good. And then Logan, how am I going to find area of the total? The big.
2x squared plus 8.
Good job. Now guys, don't forget, I know both of these examples are rectangles, but if it's a circle or triangle, you have to use those formulas, okay? Now, Cullen, what am I supposed to do from here?
Can't, no. See if we can take anything out.
Okay, see if I can factor this further. Since I kind of set this up, let's see if we can factor it further. Aaron, when you look at this, do you see anything that might be able to be factored further?
The bottom set.
The bottom set, right? Because Anna, what do you notice about those two terms?
They can be divisible by 2 and they have x's.
You can take a 2 out and an x out, okay? So I could take another 2x out front, and if I took a 2x out here, what would be left? Emma?
X plus 4.
Very good. And then I could clean this up because Casey, 2x times 2x is
4x squared.
4x squared. So I have x over x plus 4 over 4x squared over x plus 4. Now that I've factored completely, I could possibly cancel. Allison, what do you think?
X on the top and one of the X's on the bottom.
She said an x on top and one of the x's on the bottom. Keep going.
And the set of X plus 4.
And the set of x plus 4, well, what does that leave me on top? 1, okay? Even if I can't see it, there's a 1 there. 1 over 4x. Very good. Now this didn't tell me to evaluate it. It just said to simplify. So 1 over 4x. Okay? Homework today is 10 through 28 even. 10 through 28 even. 30 and 31. 10 through 28 even. 30 and 31. And this is on page 667 and 668. Remember, you can check this out on YouTube. If you get on YouTube and search for Lacey Holloway, you'll see my channel. And then this one will be labeled 11-4 Algebra 1.
Subscribe, like, and comment.
Right.